So we just finished the 27th MCQ previously, right? So now we will be going on with the 31st MCQ. So 2004 MCQs, right? So we are going with the 31st one. So this is actually from energetics, right? Unit energetics, right? As usual, right? With energetics, right? Now let's see the question. Okay, the average bond energies of C triple bond C and C double bond C are 835 kilojoules per mole and 610 kilojoules per mole respectively. Now the question is the most reasonable value of the average bond energy of the C bond in kilojoule per mole is. Okay. Now see here. So bond energy of C triple bond C. Over here you should know in triple bond we have one sigma bond. We have one sigma bond along with we have two pi bonds, right? Two pi bonds over here. That's why we have triple bond here, right? So this is an important thing that you have to know. So we have one sigma bond and two pi bonds here. So here they already said is about average, right? So the average, bond energy of C triple bond C, which has one sigma bond and two pi bonds, is actually 835, I think. 835 kilojoule mole minus 1. Same way, the average bond energy of C double bond C, which is we have one sigma bond along with one pi bond. We have one pi bond, right? So the average is actually that they have given in the question is 610 kilojoule mole minus 1. 610 kilojoule mole minus 1. Now what I am going to do is, if I subtract the bond energies between the triple bond, right? In the triple bond we have one sigma bond and two pi bonds here. But in the C double bond C, we have one sigma bond and one pi bond. So if you subtract, what will happen is this pi bonds energy will be cancelled out. In the case of pi bonds, 2 minus 1 we will get only one pi bond. As a result, you will get one pi bonds energy, right? Keep in mind, if this is one pi bond, you should not say the answer will be 835 minus 610. Why you can't say? The reason is, when you have this bond C dash C, you should know this bond is actually not a pi bond. This has to be a sigma bond. Usually, all the sigma bonds, right, may have either a single bond between two atoms or a double bond or a triple bond. But you should know all the single bonds that we have in our syllabus also in all the majority of the components have sigma bonds only. All the single bonds are obviously sigma bonds, right? All the single bonds, right? Keep in mind, all single bonds between two atoms, they are sigma bonds. So according to the question, they have asked C, single bond C. That's the question. They have asked the average, reasonable average bond energy. So you should know, for this question, they are asking this. So obviously this cannot be the answer. So this answer came by, once you subtract these two, you are going to get for 1 pi bond. This is for 1 pi bond. This is for 1 pi bond. Now you found out the energy which is there for 1 pi bond, right? Now let me say this is my, let's say this is my equation A. This one is equation B. And this one is equation C. Let's talk about that. If it is equation C. Now I have the energy for 1 pi bond. But now in my double bond, I have 1 sigma bond and 1 pi bond. Right? I have 1 sigma bond and 1 pi bond for through this question. What I can do is, if I subtract this to this, if I subtract this value from this, what will happen is, the energy which I require for sigma bond will be cancelled out. Finally, I'll get for 1 sigma bond. So finally, I'll get for 1 sigma bond between 2 carbons here. So that's the question. They have asked this question, no? So what I can do is, I can take the B equation minus C, right? So if I subtract them, what will happen is, I'll get 610 minus 835 minus 610. This is going to be the energy for C dash C. So for the sigma bonds that we have in our question. So what can be the answer? So they have given the answer 4th. 4th is the answer here. You can do this question in other way also. You can do this question in other way also. Let's see how to do it. What I can do is, I can take the B equation here and I can double them up. I'm going to multiply them by 2. If I multiply B equation by 2, what will happen is, I'll get 2 into 610 kilojoule per mole. No harm, because I'm multiplying by 2. But what will happen to these bonds? This all will become twice. Why? Because I have multiplied the equation completely by 2. So I have to consider there are 2 people here, 2 moles. This is for 1 mole. I have taken for 2 moles right now. So if I talk about 2 moles, then I have to completely think about the 2 moles over here. If there is 2 moles, then you're going to have 2 sigma bonds and 2 pi bonds. Understood? So what will happen? You will have 2 C double bond C here, which means you're going to have 2 sigma bonds plus 2 pi bonds, right? 2 pi bonds. Okay, now you have 2 sigma bonds and 2 pi bonds. What you can do? You can subtract this energy from here. You can subtract this energy from here. What will happen? This pi bond this pi bond will be cancelled out. Once this pi bonds and all will get cancelled here, what will be remaining is with one single bond. So what is the answer? Finally, you can get let's say this is D. Let's say this equation is D. So if I subtract D minus A, this is my A equation. So I have two pi bonds. Both of them will be subtracted. I have two sigma bond, one sigma bond. So finally get one sigma bond. Right? Here I had one fellow here I had two fellows. So there will be a change in their bonds. So finally what will be the answer? I'll get C dash C for one sigma bond. So finally I can get 835 minus 2 into 610. You can do in this way also. Right? Both the ways the answers will be the same. No harm. Right? In both the ways the answer is going to be the same. Right? Sorry, I have written it different way. My bad. Wait. It's 2 610 minus 835 kilojoule mole minus 1. This is the way, yeah. 2 bracket 610 minus 835 kilojoule mole minus 1. So this is the answer. Both the answers will be the same, right? If they have given a value, you will get the answer for this, right? That's the main thing that you have to know. So in this question, you have to know what is happening here, right? Why did I minus these two? If I minus these two, what I will get? That's the question they are asking. So you have to think in this way, right? So we'll see our next question, which is 43, which is actually from mining equilibrium in the next video.